First, I would like to thank the organizers, including my paper on this fantastic program. And this paper I have to disclaim, so this paper is neither deep or complex. But I think it's just like this paper will showcase, this kind of like the theme about this program, this conference, the machine learning, especially in this case, in our case, is Bayesian machine learning, has a huge potential, to help us address this serious finance economics questions. So this is John work with Wei Wang from Queen's University and Wei Yuan from Indiana University. Myself is from Pennsylvania University, Pennsylvania Wharton School. Right. So. Right, so it is well known that this kind of repeated syndication interactions can facilitate coordination, and the European Commission actually published this a report to emphasize their concerns of potential competition concerns of the loan syndication process, and the loans, they focus on the loans for leveraged buyouts and those for infrastructures. So that means the shows the regulators and the corporations were clearly paying very serious attention to market power of syndication lenders, and also even the concern about this possible collab deals among this kind of specialized lenders. So in this paper, we are going to address the question to what extent the lender's market power will affect the loan yield spread, and how that will affect this loan yield spread. Right? We want to emphasize it's not merely an asset pricing question, but also an IO question underscored identification challenges. So to answer this question, the traditional new classical asset pricing theories, like Simon just showed this equation about SDF, will not be sufficient. Why that's the case? Because under this traditional new classical asset pricing theories, the asset price is actually their unbiased estimate of this fundamental value of the asset. And this beautiful equality or relation actually built on some restrictive assumptions, right? Basically, it assumes there are fully diversified investors who can trade assets freely across different markets. And also, the markets are efficient in the sense the information is perfect, the competition is perfect, and there's no arbitrage. And yet, we know in reality, so many asset markets actually intermediated by a relatively small number of specialized institutional investors, like banks, mutual funds, hedge funds, right? So the channel of this, actually this has been studied and emphasized in the finance and macrofinance literature. People have been focused on the channels of funding liquidity and leverage constraints and fund flow risks, right? There are a bunch of papers for the past decades. But this imperfect competition among this highly specialized institutional investors has been understudied in this literature. So in this paper, we try to fill this gap. In this paper, we show the lenders' market power largely affect loan pricing for distressed firms in the primary markets. So what do we mean by distressed loans? So here we focus on two markets, right? There are actually two major distressed loan markets. So the first one, we call this the distressed loan markets. It's like the borrower's credit ratings is below triple C plus. There are 5 years of CDS spread is about bigger than 10%. And the other distressed loan market is actually, we call this debtor in possession or DIP loan market. It is like, in US, even if the firms fell for bankruptcy, right? They're in Chapter 11, they can still, raise loans from the banks. And those loans are DIP loans. Okay. I thought Chapter 11 means you don't have to repay your loans. No, but yes, you're right. This is like a resolution process. But in order to maintain this kind of working capital, to preserve the value of the assets, payers they still have to raise loans and pay that, take them running. That's a good question. So why this kind of study about this kind of like distressed loan market, how that works and matters are important? Because it shapes this kind of like financial distress cost for the whole corporate sector. And it is affect the survival rate of these financial distress firms, affect the efficiency of the bankruptcy process, as emphasized in my other paper. So, and you may say, Winston, yes, distressed loan market is really tiny, right, in this among this whole loan market of credit markets. But what we want to emphasize, the importance of one market is now equal to, or fully represented by the size of the market, right? Just think about this kind of intensive care units, ICUs, in a hospital or healthcare system, right? They're small relatively, so ICU admissions is less than 10% of total admissions per year for the whole hospital system, and the ICU beds only account for 10% of the total beds in the hospital system, but nobody can say ICU is not important. It's not important, right? So the loan markets for distressed firms, we want to draw this analogy. It's just like the ICUs in the economy. It's very important. Actually, the distressed loans in US, in total, is also about 2% of leverage loans. And also the distressed loans, actually in 2009, the total size can go beyond 40% of the leverage loans, right? Especially in recession, the distressed loan market is huge and is vital. All right, so more background of this market. Actually, in this paper, remember, we want to quantify or estimate the market power of the specialized lenders in the distressed loan market. Actually, qualitatively, it's not surprising they have market power, because if you think about the demand side, the firms who are in distress already, right? Actually, their bargaining power position is very weak, because they have their liquidity. They're in their liquidity situation, the desperate needs for the, to raise capital to survive. And also they have limited access to the alternative external funding market, right? When the firms who are already in distress, they are out of equity market, they are out of bond market, basically. They have to go to the loan market to survive. And also when they raise loans, they are facing this kind of like a really unfavorable terms, because they have a limited commitment for the future debt policies. And from the supply side, right? So why, this kind of like lenders have like a big, strong market power? Because for the distressed loans, really specialized market, right? You need to understand this kind of like resolution process of distress, the bankruptcy process. They need to have a legal team to deal with it. So there's a high entry barrier in this market. It's not like any mutual fund or banks, local banks can enter this market. So it's a high entry barrier leads to segmented and concentrated markets in which specialized lenders, they can tacitly include. So the last point is the existing creditors of the firms may discourage others from participating. Why that's the case? Because if, for example, Simon is an existing big lender, Bank of America, I want to enter, I want to enter this kind of like a syndicated loan to lend to the firm Simon already been dealing with. So Simon may want me to enter, because this can complicate things, right? And also, I understand that Simon already worked with this, this firm, knows the management team. If I enter this game, and if this firm go to bankruptcy in the end, I will be in an unfavorable position relative to Simon. So because of this, actually, I feel hesitant to enter. Put all this together, right? Qualitatively, we believe, yes, this is a few small specialized lenders. They have a huge market power in this market. So in this paper, we are going now, build on this qualitative intuitions. The goal is quantitative, which I think, the goal of this conference really well. So we want to dissect the cost of the distressed corporate borrowers. Suppose the first line, we have this risk-adjusted loan yield spread. We want to decompose that loan yield spread after adjusting for the risk into the cost of lenders and the markups due to lenders' market power. And we do, moreover, we want to further decompose this markup due to lenders' market power into two components. We want to understand how much of those is due to the non-collusive market power, how much of those due to passive collusion among these big lenders. Empirically, to answer this question, to do this decomposition is really challenging. Why that's the case? Because this collusion capacity, we don't really have a good empirical proxy for that. And also, there are latent confounding variables, in demand curve and supply curve estimation. We call that endogeneity issue. So, it's usually in the literature, in the IO literature, how people handle this is they have this DLP system, finding instrument variables, to just get out of this kind of latent confounding problem. So here, we're going to use this Bayesian learning approach to directly confront, to address this issue. I mean, that's the whole point of this paper. So to do that, first we need to build a structural model with latent variables. So instead of using BLP or IV, estimating some single equation, we estimate all the equations, supply curve, demand curve simultaneously. And in this structural model, so basically we have collusive and non-collusive equilibrium coherently built in a coherent framework. Right? In this kind of BLP framework, usually people just impose some ad hoc proxy for this collusion process or collusion equilibrium. But here, we build a more structured model, so both non-collusive and collusive equilibrium will arise in a coherent way within a unified framework. And this model we design with simplicity, so we have closed form solution, so we can use MC Bayesian estimation with to deal with latent demand shifts. So in general, you can, when this structural model is complex enough, even without closed form solution, you can use Bayes machine learning for classification to estimate this. The idea of the logic is exactly the same. And we want to emphasize it's very different from BLP with single equation estimation plus IVs. Right? So motivating facts. I mean, this is a review of this paper. So motivating facts. Actually, first I want to show you this kind of risk-adjusted long yield spread is huge in the distressed loan market, in both the distressed loan market. So first, in the distressed loan market, which for firms before bankruptcy, the risk-adjusted loan yield spread is over 300 basis points or 3% left on the table. This cannot be explained by any risk premium or liquidity premium. Okay, and for the DIP loan market, what's left on the table is even more striking. Is over 7%, over 700 basis points. After we remove the credit spread component, remove the liquidity premium component, which means there's huge amount of returns of yields in this market cannot be explained by SDF. Right? So how to, in this paper, we try to understand those numbers. And the first attempt is trying to convince you, actually these two markets are highly concentrated. So here, the first, this panel is for the distressed loan market before bankruptcy. And this is for firms in the bankruptcy. So this is a rank of the big players according to the number of deals they've been involved. Okay, so you can see for the first one, for the distressed loan market, the top one is Bank of America, and then JP Morgan Chase. And the number of deals they involved decreased very quickly from top 1 to top 10, right? And also for the deep loan market, you see the similar pattern. This is a sign, actually it's highly concentrated, this two market. And then another measure, more common measure is this. So here we kind of classify the lenders into 3 types. First, the existing players, which means, the distressed loan was made by the banks or the lenders who are already making loans to this time. Second type is the specialized lenders, which are the lenders by definition is among the top 10 players in each of the markets. So the last one, type 3, we call land of last resort. It's kind of abuse of the term land of last resort. Here we need private equity firms or hedge funds. Okay, this is really the last result. This distress fund would go because the funding cost is super high. We can say, the type 2, which means the specialized lenders released here on this on the panel A, actually they count for 76% fraction of the total distressed loans in terms of like numbers of deals, and over 90% of the market in terms of like dollar value of the loans they made. This is for the distressed loan market. For DIP loan market, it's the similar numbers. So it's highly concentrated. Most of the loans actually in either markets are made by the syndications of this top 10 banks. All right, so another thing is this figure trying to show you, another way to show the concentration. So here we list from top 1 is for distressed loan market before the bankruptcy. The top 1 to top 30 is the y-axis. The x-axis is a similar thing. For each cell, the color, the intensity of the color represents how the number of deals these two banks syndicate together. So you can say actually the top 10 ones, they mainly syndicate with each other. They don't even syndicate with some smaller banks, right? So this kind of like a concentration plus repeated relations of the top 1, just raise the concerns, right, of this class exclusion. And you may say this high number, I showed you this average number, right? It's 3%, 7%. It's huge, but they may you may say, okay, my sample covered this kind of like financial crisis, 2008. It's maybe just due to that 1 year, maybe. But here I plot the time series for the distressed loan market from 2000 to 2017, and this is the DIP market from the 2001 to 2018. The red curve is for every year, is the average spread, risk-adjusted spread. You can say it fluctuates a little bit, but on average, they stay high. It's not like just due to one spike. And also, here I showed you the last, piece of motivating facts. If it's due to competition, right? This is due to markup. So for the loans, for the syndication, if we see the number of syndicators, if the increase, the V2M increase, the spread should decrease. Actually, you see that's the case for most market. Okay. So this is like motivating facts. So now let's go to the model, try to understand what we have seen. We try to make the model as simple as possible. So first we look at this kind of demand side, which means the firm's demand for the loans. Right? It's the linear demand curve. The left-hand side is log loan to asset ratio. It's like a quantity. And the right-hand side, the R is the spread, risk-adjusted spread. And the alpha is the intercept term of this demand curve, capture this kind of like, the desire for this firm to want this loan. And this epsilon capture the elasticity. And the little k means here, this is a key thing, right? So basically, for the BLP system, overall, in general, for IO questions. So this cross different deals, this demand curve can shift. That's why it's so hard to estimate. Here we have to embrace this, fully embrace this. So basically, alpha, you can see the alpha depend on k, epsilon depend on k. Instead of thinking there's a continuous variables, so here we kind of like assume there are clusters, the demand curves. There are few demand curves, but both the alpha and epsilon can change. And this capital K can be big, right? When the capital K is big enough, it's a good approximation for the data. So we want to say actually this specification, simple specification, is in some sense is like more general, more flexible than the BLP's demand curve shift, because there for BLP system usually people fix the epsilon, just shift alpha. But here we allow both changing in a latent way. So this kind of Bayesian machine learning approach will help us to estimate other parameters at the same time, identify, you give me one case, which demand curve this firm should belong to. Okay, from the supply side, remember there are three types of firms. Three types of lenders: existing lender, specialized lender, one of the club members, and the lender of last resort. In this case, is like PE or hedge fund. So for the existing lenders, the lending question is very simple. Usually, it's more like a monopolist lending with marginal cost e to the power phi 1 plus var epsilon times u. U is like a deal specific cost shock, and this epsilon, this phi 1 captures this average marginal cost of making this loan. So the second type is, suppose we have capital M, actually in our case, right, capital M equals 10. There are 10 specialized lenders. For each deal within the syndication, they kind of like doing this kernel computation with marginal cost e to the power of phi 2 plus var epsilon times u. Again, use a deal specific shock. And here differently, phi 2 is different from phi 1. And for each specialized lender, the decision whether they will going to enter this deal is endogenous. They're going to receive this kind of like this utility of participating in this syndication, which is W, and W follows this exponential distribution, and this mu parameter, which is important, will capture this average utility. So it captures how difficult for this kind of like specialized lenders to enter this deal, enter this syndication. So this mu mainly captures the blocking power from the existing lenders. And the last type of lending is lender of last resort. Again, it's monopolistic lending with marginal cost e to the power phi 3 times plus var epsilon times u. And then importantly, the average marginal cost, phi 1, phi 2, phi 3, they're different. And intuitively, we would expect that phi 1 is less than phi 2, less than phi 3, but we're not going to impose this relation in the estimation, but the later data will tell us whether our intuition is right or not. So nicely, the game will play out for each deal will play out in a sequential way. So first, when a borrower, right, is in a distress, they want to raise small distress loan to survive, they first talk with existing lenders. That's the first step. So with certain probability, lambda k, they will reach agreement. If they reach agreement, then that's easy. They just have to raise the funding from the existing lender. They will go to monopolistic lending of the existing creditor. The game is over. But with certain chance, 1 minus lambda k, they're not going to reach agreement. Okay. Then this borrower has to go to this kind of like the specialized lenders. This 10, let's say this 10 big banks, right? Ask them, I need this amount of money. So what terms you can offer to me? So there, each of the specialized lenders, they will talk to each other, and then they will evaluate this kind of idiosyncratic, this utility of participating in this loan, and then evaluating, the expected profit from this, from making this loan, and then they will decide, whether they are going to participate in this loan or not. So basically, if they're in equilibrium, there will be an endogenous cutoff point, W star. And if for specialized lender I, the disutility is less than or equal to this, they will going to participate. And if it's bigger than this, this lender, specialized lender, which decide not to participate. And if there's no, in equilibrium, there's no specialist lender is willing to lend, then this deal has to go to the lender of last resort, go to hedge fund and PE fund. And there, they were facing this kind of like a high fee and the monopolist lending by the PE or VC. So this is how the game is played. Okay, so now let's zoom in how to do it given all these specifications. So here for the existing lender, it's very easy, right? It's a monopolistic lending problem. It's like this lender just pick this L, the amount of lending, give the demand curve of the of the firm, distressed firm. So maximize the profit of this lending, and we can solve everything analytically. And the second step, if they're not going to reach agreement for this step, you're going to the second step. Suppose there are M participants in the syndication. in this case, the value function of the specialized lender at the beginning of the beginning of this period, when the DSE utility, idiosyncratic DSE utility, and the type of the firm and the X, which means captures all other characteristics of the firm, borrowers already observed. So the value of this lender will be equal to this. And then this is equal to this utility minus this DSE utility you're participating, which is W. And then this utility U follow this Bellman equation. It's very simple, intuitive. It's equal to the, if they're going to land according to their agreement of the syndication LC, C means collusion or coordination. And according to this is a current period profit by making this long, and plus the future value, some continuation value of this agreement, and the continuation value equals to the expected payoff. If this guy from next deal, with certain chance, this guy is the existing lender, this is the profit who made as an existing lender, and with some chance, this firm is not, this lender is not existing creditor, rather than just play this like specialized lender syndication with others. In that case, with this probability, we'll go to that case, and the conditional, this kind of W prime next period, this kind of idiosyncratic, this utility is less than equal to the equilibrium one, and it will make a loan. The profit will be equal to the revenue of the loan minus the DSE utility W prime. So this is the equation. And if each firm they can choose to deviate, right? Given this agreement LC, they can choose to deviate. If they deviate with certain probability, CASI, they will be punished in the next deal. The punishment is they will be kicked out. They're not going to, no one wants to enter this collusion or coordination with this guy in this syndication. And if that's the case, to guarantee no specialized lender would like to deviate, they have to make sure this SA constraint is not violated. The SA constraint is the expected utility under the collusion is bigger than or equal to the expected utility if the lender chooses to deviate. Right? If that's always true, so no one on the equilibrium path, no one will like to deviate.
Sorry, are you assuming that if they syndicate, they are colluding?
Yes, so basically, yes, you're right. So basically, here we're assuming they are colluding, but how much they're colluding is it depends on this parameter CASI. How well they can collude, right? If CASI, for example, is 0, which means there's no chance will be punished if you deviate. So this collusive equilibrium will just identical to the non-collusive equilibrium, right? If CASI is high, if everybody will know, right? If I deviate this period with high chance for next deal, I will be punished. Then everybody want to, behave better in this deal, so collusion is easier to be.
Right. So the estimation will only be about how much they're doing. Yes. If you see syndication in the data, you will assume that is good.
So that's the question. So we're going to test, right? So we have the structural model. We're going to estimate this coefficient CASI. But if the CASI according to the estimation is not significantly different from 0, so we say, yeah, the data maybe not, there's no collusion in the data. But later we'll see the CASI is very different from 0. And we do formal test. Thank you. Okay. So yeah, this is the key part of the model. Actually, it's very simple. It's just a typical, repeated game. And more intuition, right? So basically, you can think of each deal, there are 2 equilibrium the specialized lenders can enter. One is exclusive equilibrium, which means a smaller loan size, higher spread. In this model will lead to greater revenue. Revenues of non-collusive equilibrium, which means we compete. All the specialized lenders, they don't call it, they compete. They want to lend more, and which in the equilibrium will be larger loan size, but low spread leads to smaller revenue. And of course, because the the inclusive will give you the greater revenue. The inclusion is preferred by the specialized lender, subject to this asset constraints, right? So, and also inclusion is sustained by punishment for deviation. And if you deal what you deviate, the equilibrium for the next deal will shift to non-inclusive equilibrium with appropriate CSI. And CSI again capture this inclusion capacity is something we're going to identify and estimate using the Bayesian learning, machine learning approach. So, but even here, right? So I think even with asset constraint satisfied, there can be many equilibrium, inclusive equilibrium. So we have to learn to estimate. In theory, we have to guarantee there's a unique equilibrium. So very intuitively, according to our equilibrium selection procedure, we focus on the one who give the specialized lenders the highest average profit. Okay, just like asset constraint is binding state by state. Okay, so if for this kind of specialized lender equilibrium for certain deals, right, there's some randomness, no one wants to lend. So this deal has to go to the lender of last resort. The lender of last resort, again, facing this kind of like monopolistic lending, PE or VC, and they have this kind of like a high marginal cost of funding. So that's why the yield the cost of the borrowing will also be high. So this is like here we can solve this analytically, very simple. So this is about the model. And now the data and estimation. So in this paper, we kind of combine a few different sources of data. I'll just skip this part. If you're interested in this, you can go through look into data the paper and estimation. So it's actually this is a really tight model. It's not, like I said, it's not complex or deep. So here we have this kind of alpha k, epsilon k, and this capital K can be big. It's like capital K captures the number of latent demand curves, in this market, and then the punishment deviation is psi, which is between 0 and 1. So this is an important parameter we need to identify and estimate. And the participation disutility or blocking power of the existing lenders captured by this parameter mu is also important. And also the latent variable costs, phi1, phi2, phi3 for each type of the lenders. And the latent variables to estimate are this kind of like this little k. So the capture, is a label capture which demand curve for one borrower belongs to it. And we use this MC Bayesian estimation or Bayes machine learning for classification. So we utilize observables. Not here is the key thing is like we're not only observe the prices, loan prices, but also we observe the lender type, the number of the lenders in the syndication, and the loan size. So put all this together can help us identify the system. And we estimate the posterior distribution of the model parameters. We treat the latent demand shifted K as an auxiliary classification, and it's different from the traditional methods. I want to emphasize again, right? If you do BLP or other IO approach, right? So there, the whole idea of the IV is try to say, forget about this K, this latent variable. With IV, we don't need to worry about this. But here, for Bayesian machine learning, it's like, no, we will let machine to learn about this K. So that's the key difference. If you get this, that's enough for the talk.
And sorry, what about the supply side? What about the supply side? How are you estimating the marginal cost?
The marginal cost? Yeah. So everything will be estimated continuously. It's like in this kind of.
So, but that also is not by IV. There's no random variation that you're using to get the marginal cost of the lenders.
The marginal cost, yes. So here the marginal cost is modeling this way, right? So we have come back here, right? So this is how we specify. So importantly, so here we have this, this kind of idiosyncratic shock. But you're right. This can also, depends on some like types of the lenders, some latent classification. We can also do that. But here, remember, here we only have 10 lenders. It's not like borrowers, we have a couple of lenders, right? So there, we have really cross-section is useful for us to treat the heterogeneity, latent heterogeneity more seriously. But here we have 10 specialized layers here. So it's we just model like an exogenous DO case, DO specific exogenous shock to model the heterogeneity. But we can do it if you have more layers, and even with 10, maybe you have 2 types. Yeah, we can do this.
Yeah, but even without the heterogeneity, I was just wondering what is the source of identification of your supply side? How is this? So why is marginal cost 1 rather than 2? If you get
okay, so this whole thing here, right? So this kind of like Bayesian learning is I can think it's like an iteration way. Right? First, for example, if we can well identify for each demand curve, for each deal, which demand curve it belongs to. Right? And then basically within each case's demand curve with the supply curve together, we can pin out equilibrium so we can estimate everything. And then we take this estimation, we iterate, we see whether this classification of the demand curve is reasonable, whether we can improve. And when we improve the classification, we re-estimate everything. Okay. Yeah, we can talk more after. Yeah. All right, so this is the estimation result. So the key parameter estimation is the CASI, the occlusion capacity. For the distress loan market, it's about 0.8, and for DIP loan market, it's about 0.5. And here is the standard error. You can see it's significantly above 0. That means, yes, we see significant occlusion here. And also we can do formal tests. We see, which moment, which data feature kind of reject this kind of like, non-inclusive Nash equilibrium. So here is the data. So here is like an average loan to asset ratio for this kind of deals or syndications with more than one syndicate specialized lenders. Divided by here, the denominator is a loan to asset ratio for the deals. We only have one, which is a monopoly specialized lender. Why we look at this two ratio? Because if the occlusion is perfect, right, perfect cocktail, no matter how many number of syndicators you have in this deal, they should behave like a perfect cocktail, like a monopoly. So this ratio should be close to 1. Okay, so this is the data. You can say it's a slightly above 1, it's close to 1. And this is our baseline model, which will allow occlusion. You can see the estimation, the match the data pretty well. And this one is if we like by brute force, we can shut down the possibility of occlusion in the model. We estimate the model and we see what is like a modeling moments for this is much higher than the data. So actually in the model and data, it is this ratio to help us to pin down, identify this CASI, occlusion capacity. Right. So for this is from distress loan market, for DIP loan market, actually very similar pattern. And here is the estimation, right? So basically, the x-axis, the estimation of demand curve is the log spread, risk-adjusted yield, and the y-axis is log loan to asset ratio. And you can see here is importantly, we found like 2 clusters. The machine tells us actually there are 2 clusters of demand curve. One is like this, the other one is like this. Okay, this is for distress loan market. And if we don't do this, use machine learning approach and the Bayesian machine learning approach, we just like fit this kind of reduced form, right? This would be the demand curve. It's totally wrong. It's very flat, but actually if we recognize let the machine tell us, what is the latent potential demand curve shifts, how many of them there are there? So it will tell us 2, and this is the classification. So the demand curve estimation will be like this. And this is for the distress loan market, and this is for DIP loan market. Actually, the data tell us it's better to have 3 demand curves, 3 clusters, and this is 3 of them estimation. And then we look at this kind of like induction, one important induction variable, which is the size of the syndication. So the number of specialized lenders in the syndication. So the black bar is represent the distribution of the model, and the white bar represent the data. You can see the distribution matches pretty well. And this is the for distressed loan market, and this is for DIP. And in the end, we want to decompose, right? So for this number I give to you at the very beginning, one is 3%, the other one is 7% in the DIP loan market. How much of them can be attributed to collusion and the blocking power, or just a monopoly competition and the variable costs? So here, the black bar is for the distressed loan market for firms, distressed firms before bankruptcy, and this is for them in the bankruptcy. You can see for both markets, actually, this is about 200 basis points, 2% are due to collusion. How long?
You're done.
Oh, okay. 1 minute.
Standing up to signal to you that you should.
Oh, sure. So it's yeah, almost there. And then you can see this is like actually it's very intuitive, this estimation, because I showed you these two columns, who are the specialized lenders. They're almost the same firm, big banks, Citigroups, Bank of America, Wells Fargo's, right? So the collusion capacity should be similar. So the collusion, the spread due to that is also similar for two markets. And this is for blocking power. You can see for the DIP, for the distressed loan market, it is about like about 1%, but for the DIP loan market, it's much higher. It's also very intuitive, because remember, the DIP loan market is also the firms in the bankruptcy. Actually, usually in that case, the existing lenders, they really don't want to introduce new creditors to compete with them to mess up this, this bankruptcy process, right? So the blocking power is higher. And actually for this kind of like just oligopoly competition part, non-inclusive markup is really small. And for variable cost, you can see for the DIP loan market, it's much higher. The reason is, yes, it's more complex. It's more costly to make loans for the firms already in bankruptcy. So it's also very intuitive. So that's a decomposition. So we also do some policy analysis. I can just skip if you're interested in this, just read the book, read the paper, and I'm happy to talk more about those policy analysis. And let me conclude. So in this paper, we study intermediate asset pricing based on market concentration and the coordination. And we introduce a novel source of financial distress causes due to the collusion of market power of the lenders in the distressed loan market. And we show that imperfect competition will lead to a large cost for distressed borrowers, especially smaller ones. And because of this, in terms of policy, we want to recommend that the policy should, for the antitrust policy in the distressed loan market, should focus on this smaller borrowers, and also focus on the government lending facility, which can be more effective. It's easy to implement. No more hazard, no credit accessibility harmfulness, and instead go to the interest rate cap for the commercial loans, and also target on the smaller borrowers. Yeah, that's about the paper. Thank you so much.